All right, so this is where we left off. Again, I'm not going to explain these formulas. Feel free to Google them, write them down, use them. You can use formula sheets on your upcoming test, especially when it pertains to this. I do not expect you to memorize. Because you have to think about, if I were doing this problem, I might think about doing a sum. Like I would do 45 plus 30. But I'm going to follow the directions because it asks for a difference. So I think they just want you to practice doing, a difference on this one and then a sum on this one. So there's more than one way to do these problems. The toughest thing, in my opinion, and you can argue with me, and that's fine, is to think about how 75 degrees, maybe that's the same as, I feel like we just did one that was 120 minus 45. And you can double check with the calculator. There's no problem if you're using a calculator because you still have to give the exact value. 120 minus 45, we just did that one. It's 75 degrees. Okay, so we should get a positive answer, just so I'm clear. Whoops, I meant to make that a fraction, not start writing right away. What we have then is tangent of 120 degrees minus tangent of 45 degrees over 1 plus tangent of 120 degrees times tangent of 45 degrees. Now what's nice about the 45 degrees, I've mentioned this before, is root 2 over 2, root 2 over 2. Well, as far as tangent goes, sine over cosine, that's 1, anything divided by itself is 1. So at the very least, I would expect all of you to know that this is minus 1, and then we have 1 plus something times 1. So it's a very, very useful angle to look for. Now 120 degrees is not as nice. It's negative 1/2 root 3 over 2. But as you get a lot of practice and you do sine over cosine, you'll notice that the 2's will cancel. So we're just looking at negative root 3 over 1, sine over cosine again. So it's negative root 3 minus 1 over 1 plus negative root 3 times 1. Now I am fine, and I'll even show you with the answer key that some people are fine just leaving your answer like this. I guess I could have written it like that. But this is a positive angle. And you can actually see that he used the same trick that I did. 120 minus 45. And while I'm at it, I might as well, because I think the trickiest part is thinking about what two angles are on the unit circle and add to be 165 degrees. Because you can't just do any two numbers. You have to actually strategically think about what two numbers will add to give you 165. But notice that I think he strategically chose 75 and 165 for problems here because notice the formula is pretty much the same. So it was just a chance happening. I'll let you pause the video and work through this. So again, I'm fine if you leave your answer in this form or if you do a little bit of manipulation to get into a simpler answer. But when I say exact, I mean I want exact, not decimals. If you plug it in and you start writing decimals, I'm going to assume you just use the calculator to begin with and you typed in tangent of 75 degrees, which defeats the purpose of understanding this formula. All right, so there's your work for the second part of this. I'm going to move on. And if anybody wants me to work through this, just ask me in class, ask me in a Google Meet, something like that. Because what we're going to ask you to do is a little bit more work moving on to the next one. So we have a lot of information here. First of all, let's just imagine theta for a second. So sine is 3/5 and tangent of theta is positive. So the only time that sine is positive and tangent is positive is if we're in the first quadrant. This is not very good. So theta has to be in the first quadrant. By definition, sine is opposite over hypotenuse, and this is a 3, 4, 5 Pythagorean triple. Very useful. So as we look at the next one, sine is positive again for alpha, but tangent of alpha is negative. So alpha needs to be in the second quadrant in order for sine to be positive. That's a very poorly drawn. It doesn't matter. So alpha is in the second quadrant. And again, sine is opposite over hypotenuse. But this is a 5, 12, 13 Pythagorean triple. If you don't believe me that memorizing Pythagorean triples is not useful, well, then you'd have to go through the Pythagorean theorem to solve both of those. And I should put that this is negative 12, because that's very important. Because if I ask you to do sine of theta plus alpha, I need to put parentheses, by the way, and you go to your formula sheet that says, okay, well, that's sine of theta, cosine of alpha, and then plus cosine of theta, sine of alpha. Well, all you know right now is that sine of theta by the directions is 3/5, and sine of alpha is given to you in the directions 5/13. But you have no idea what cosine of alpha is or cosine of theta. But by drawing the picture and understanding that cosine is adjacent over hypotenuse, now you know that that's negative 12/13. And cosine of theta, it's adjacent over hypotenuse again, is 4/5. So now we can answer, and maybe I should have highlighted what I was doing. I was doing this piece right here. Yeah, now you can actually work it out that you would get negative 36. And I'm just multiplying straight across. I imagine you can do this in your head. 3 times negative 12. 5 times 13 would be 65. Plus 20 over 65. So adding that together gives me negative 16 over 65. And before moving on, I want you to realize that that answer makes sense. Because if you think about where theta is, so theta, as I mentioned, is in the first quadrant somewhere. Well, if I were to add to it this, and I told you earlier that I drew alpha really poorly because my length of 5 looks like it's the same length as 12, but it's a better angle would have looked more like this. But I don't really feel like rewriting it. So if I were to add this obtuse angle to theta, I end up somewhere over here in the second quadrant. Think of where an obtuse angle would end up. Did I say the third quadrant? I don't know. I should get a negative angle for sine. Yeah, and I could stress that all day that your answers need to make sense, but I'm not going to. So now doing cosine of alpha minus theta. Remember, it's cosine cosine plus sine sine. So as you look at all of your pieces, cosine of alpha was the negative 12/13. Cosine of theta was 4/5. And then plus sine of alpha was 5/13. And sine of theta was 3/5. So doing that math looks like it's negative 48, if I'm doing my math correctly, plus 15 65ths. Negative 48 plus 15 is negative 33. And then we have one more to do, but I think I'm going to jump to the answer key because I'm always nervous for doing these types of problems in my head. There we go. And I would even argue this person did not do a good job of explaining where alpha is. I don't even like how he writes. That looks like a zeta. That's a different Greek letter. But anyway, no, that's a 3. Man, that's an ugly 3. Anyway, so the math does work out. Notice that all of our answers, and I've mentioned this before, but I think it's good to repeat yourself, is that all of your answers for sine of an angle should be bigger than -1 but smaller than +1. And all of my answers are bigger than -1 and smaller than +1. That is not true for tangent. So I'm going to leave this up here, and you can see how do you get tangent? Tangent is opposite over adjacent. So you can see that tangent of theta is 3/4, and tangent of alpha is -5/12. And subtracting a negative turns it into positive. And a little bit of arithmetic and dividing by a fraction is the same as multiplying by the reciprocal, so double check your math. But I really want to stress why it's okay for tangent to be positive. So go ahead and pause and make sure you understand this. And if seeing the answer does not make sense, bring it to class. But I want to move forward and talk about this real quick. If you look on any right triangle, doesn't matter how I draw this, across from the right angle has to be the biggest side. Because the only way to have a right angle is if the right angle is the largest angle. So as you look at sine and cosine, theta or alpha, it doesn't matter, what you get is opposite over hypotenuse or adjacent over hypotenuse. But no matter how you chalk it up, the bigger of the three numbers, the biggest of the three numbers, I guess I should say, is the hypotenuse. So what that means, I'll just write small. If you take a small number divided by a bigger number, or biggest number, it has to be less than 1. Now there's an exception to that is when we get to or equal to 1. But tangent does not hold that same statement, because which one of these two sides, which leg is bigger, well, they can switch. Sometimes, if I made a triangle that looked like this one is bigger, so opposite over adjacent, smaller than 1. But sometimes in a right triangle, the adjacent is smaller. So that's why tangent can be any number, whereas sine it has to be at least or no bigger than 1. I guess I should clarify how I said that. And then we're going to show using trig identities. And I think I'll just show you one because I'm already at 3 videos, and then share the answer key as I've been doing. So the whole premise of this is that you are practicing using the formulas that we've just learned. That we have cosine of angle, cosine of x, and then plus sine of the angle, sine of x, first angle. Anyway, on the unit circle then, you could say, okay, well, pi over 2 is right here at 0, 1, so we're looking at 0 times cosine of x plus 1 times sine of x. Well, 0 times anything is 0, and 1 times anything is that thing, so that equals sine of x. And really, you can work through, and notice I'm just doing the left side. The left side, only working with one side at a time until you get to the right side. So again, I'm just going to go to the answer key because my videos are very long as it is. So that answer was down here in this corner. There we go. So you can match up where the correct answers are. I don't know why I got switched around, but hit pause. Try them on your own. Make sure that you get this, because we will be verifying these types of identities as well. Right now would be a good time to hit pause and make sure that you understand the math behind this. As I go back to my notes, here's more practice of the same thing. So you can work it out this way. Cosine of 3 pi over 2, cosine of x, and then it's plus sine of 3 pi over 2, sine of x, and then plus, we have another one, cosine of 3 pi over 2, cosine of x, minus sine of 3 pi over 2, sine of x. Now, as you notice, cosine of 3 pi over 2, I'm trying to hurry, is right down here, 0, negative 1. So this piece is 0, this piece is 0, a positive, subtracting, everything cancels, and you get 0 And you should be ready for your homework now.